Okay, again they want us to solve for time. It says two cars travel in the same direction along a straight highway, one at a constant speed of 55 miles per hour and the other at 65 miles per hour. Assuming they start at the same point, how much sooner does the faster car arrive at a destination 7 miles away? And then the second question is, how far must the faster car travel before it has a 15-minute lead on the slower car? So both these are going to be basically the same kind of method for solving. The first one, it wants to know they're driving 7 miles away, how much sooner does the faster car get there. So we got to figure out the exact amount of time that it takes both cars to get there, and then just subtract the faster one from the slower one. So if we remember right, velocity equals distance divided by time. And we can solve for time. Basically, algebraically, that would end up looking like time equals distance over velocity. And the way that that happens is, and I'll undo that. The way we get there is you can multiply both sides by time. So t times v equals d over v, or d over t times t. The t's cancel each other out, so you end up with t times v equals distance, and then you can divide by v on both sides to get t, because the v's will cancel out, t equals d over v. So this is how you solve for time. Time equals displacement divided by velocity. Okay, so with that said, we can take their displacement, which was 7 miles, and we can divide that by the faster car's velocity, 65, and we got to make sure it's in the same units, miles per hour, which it is. And what we end up getting is this is 0.11 hours. Now it wants to know minutes. How much sooner did the faster car get there in minutes? So we're going to end up having to convert this to minutes, which so 0.11 hours over 1, multiply that by 60 minutes in 1 hour. So now our hours can cancel, and we get 0.11 times 60 equals 6.46 minutes. Now we gotta take the slower car. He traveled the same distance, 7 miles, and he did it in a different velocity of 55 miles per hour. And so his speed was his time was 0.12727272, and that goes on and on forever. And so we convert that to minutes by timesing it by 60, and we get 7.6363 forever and ever 63 minutes. So we had a 6.46 and a 7 point, so we're going to subtract 6.46 to find out how much sooner he got there. We're going to round this up to a 4 and can't get rid of all that, and we get 1 minute, 1.18 minutes. So now it asks how long will it take to get a 16-minute lead? How far must the faster car travel to get a 15-minute lead? So what distance does he need to go? So we remember that distance. So x divided by velocity. So our distance, which we're going to say is x miles divided by 65 miles per hour is how far. That's the amount of time. That's the amount of time it's going to take him And so we want to say that and we'll times this. We want to get this in the number of miles. And so if we say that distance divided by velocity equals time, so this is the time it takes car A to travel X miles, and if we subtract that from the time it takes car B to travel the same number of miles per hour, that should equal 15 minutes. We're reporting in hours. So if we convert the 15 minutes to hours, then over 1 times 1 hour and 60 minutes, it equals 0.25 hours. So basically this equation is going to equal 0.25 hours. So we can go ahead and solve. So what we're going to do is go ahead and solve that equation, and the way I'll do that is I'll just go ahead and add x over 55 to both sides. So I get x over 65 equals 0.25 plus x over 55. And then I can multiply both sides by 65, so I get x equals 16.25. And when I'm using the distributive property and distributing the 65 to here and here. So 16.25 plus 65x over 55. And then I can multiply both sides by 55, again using the distributive property. I get 55x equals 893.75 plus 65x. And now I'm going to subtract 65x from both sides. It's going to be negative 10x equals 893.75. Now, this may be confusing with the negative 10, but what we're actually looking at is the final displacement. So displacement can be to the left, to the right. It really doesn't matter. And in this case, it doesn't matter either. So it's just saying that this is 10x meters behind. So divide both sides by 10, and x equals 89.38, and you don't really need to put negative. So you just say that he has to travel 89.38 miles to gain a 15-minute lead.